of water scarcity that they define pretty exactly. So this red level is physical water scarcity. This literally means that they don't have groundwater supplies, they don't have surface water supplies. The water is physically not present. Economic water scarcity is this orange color. That means that for whatever reason, whether it's a low GDP, whether it's a lack of infrastructure, those countries can't get at the groundwater. It's economically not feasible for them to access the groundwater. Could be deep aquifers, could be all sorts of challenges. And then these blue colors are sufficient water. Yeah?
What's the kind of light red, like in the Central Africa?
These ones?
Yeah.
That's the economic water scarcity.
Okay, that's the same as...
Yeah. So, there's some countries on here that you're sort of surprised about. Some of them we can predict. I mean, this is a desert belt. We've already talked about the Middle East and a lot of those countries as, that is a physical lack of water. Some other countries, people, when I present this, are surprised to see. For example, every country in the Caribbean, with the exception of, can you see what that is? Haiti, has sufficient water. A lot of these, people ask, well, what about countries like Cuba, where people are poor? In a lot of countries, depending on what the government is, water is very controlled. So there's lots of water remaining because it hasn't been overexploited. So it very much depends on what the environment is. Do they have water or not? What the political system is. Do they have access to water, and what kind of access? And third, what kind of GDP of the country is there? Can they actually build the infrastructure to get at the water? So there's lots of different reasons why you see various countries that may be surprising on that list. But the other idea is that there's a lot of people who are living in water-stressed areas, primarily here in the Southern Hemisphere. And there's no single cause for this, is part of what I was emphasizing. Some of it's just climate and geography. Some of it's a lack of water systems and infrastructure. And a significant portion of it is lack of adequate sanitation, sometimes mainly due to lack of infrastructure again. So of those, of the people, 40% of the world's population is lacking access to sanitation systems that are separate from drinking water, which we talked about as being one of the great factors of the Roman civilization. They were early on able to separate, and have wastewater separate from drinking water. And this is correlated with some of the statistics I gave you in the beginning, that waterborne illnesses affect every 1 out of 8 children. The pollution that we see is a large problem as well. Some of this is agricultural pollution in the sense of pesticides and fertilizers. Sewage is the most common issue, as I discussed on the last slide, just lack of separation of wastewater from drinking water. But there are some, developed nation problems as well in terms of industrial waste and high levels of arsenic, mercury. Some of these have come from mining, some of these have come from other extraction. But the idea is, and we'll talk about this, that understanding water quality, I'll get to this at the end, is also very important for being able to talk about water sources. What do we think is going to happen with water scarcity? Well, unfortunately, this is where we get the predictions that were made by the UN and other bodies. It's not projected to get better under climate change scenarios. So this looks at, from 1995 to 2025, what's going to happen in terms of water withdrawal. So this is how much water is being drawn as a percentage of the total available. You can see that the orange and yellow are where there's over 40% of the available water being withdrawn. Between 20 and 40 is the light yellow, over 40 is the darker orange. The rest of the countries are withdrawing 20% or less of their available water. As you look at in 2025, you'll notice that that orange and yellow belt has increased and includes the countries like the United States, which people are often surprised to see us on the map. But we'll break down a little bit of what's happening in terms of where that's headed. So water scarcity is projected to worsen as time goes on, based on climate change. And what's the other thing that we stress in terms of water? What's increasing? Yes, population is increasing. So if you don't put in conservation measures, yeah.
What does it mean, 20% of the available water?
So that is both groundwater and surface
Yeah, what does
water.
that percentage mean? Percentage of available water?
I think it's just done by acre feet, so how many acre feet are withdrawn versus the recharge rate of those aquifers per year.
So 20% per year?
These are annual numbers, yeah.
So that means in 5 years, that will be...
No, it's assuming a recharge, so it's assuming it factors in precipitation and how much is recharged in ground aquifers per year. So it's how much is coming in, how much exists, and then how much is removed.
So how much are we withdrawing every year from? I mean, what will happen in 10 years or 20 years? I mean, because based on this number, I don't quite understand that.
So the idea that they're getting at, I mean, and some of it is, this is put on by the meteorological organization that orders the data. So what they're primarily concerned with is precipitation input. And so they're measuring inputs, sort of standing water levels, and then outputs. So it doesn't mean that if you're using 20% that it would be gone in 5 years. It means that if nothing changes about the inputs, you could, and you only withdraw 20% per year, that's sustainable. Does that make sense? And only if the inputs change through something like climate change, etc., or the withdrawals change based on population levels, will you jump from, say, 20% to 40%? Good. Clear enough? Which sort of leads to my next slide. It's almost like you saw it, but how do those numbers change? And they change based on, now you'll see a lot of different units flash up in these slides, but water, for the most part, as I'm measuring it, is measured as a volume. So we're either looking at cubic kilometers, or we're looking at what they call acre feet, which is the amount of water it takes to flood an acre to 1 foot depth. So that's a less visual measurement in the sense, I mean, we're less familiar with acre feet than we are cubic kilometers, but they're both giving you some sort of volume of water you'd be changing. So this one is in cubic kilometers, and we're looking from 1900 all the way up to the year 2000, and looking at what withdrawals are being made by sector of the society. So the first story is all 3 sectors are withdrawing more water. And for the most part, they are, increasing somewhat proportionally, to where they initially started. We had very little domestic use in the beginning, mainly agricultural. If you look at the end, there's still a lot of agricultural withdrawals, industrial withdrawals, and withdrawals. So, I mean, this indicates that, programs where we reduce water use on a domestic level are very helpful, but we need to look at agriculture for some of the major changes. Now, I always ask this, I teach a conservation biology class on campus, and one of the challenges of conservation biology is very few people, if you ask them, would say, yes, I want to use up every single resource on this planet. I'm okay with letting everything go extinct. I don't care about the polar bears. Very few people will say that. But what's the conflict? Why then do we keep overexploiting resources? For example, my question specifically in this one is, why don't we just reduce the amount of water that goes to agriculture? Yeah.
Because then chances are you reduce the amount of food that's grown, and we have a lot of people eating that food and accustomed to eating that food.
Exactly. So I could give a parallel lecture to this that is looking at food shortages in the world. Because there are a lot of places where there's not enough protein, grains, food to support the population at a healthy level. So if we just put it on a water policy that says agriculture gets less water, we are also dealing with hunger. How do we feed as many people as you have? So I bring that up early on because in some ways, proposing solutions to how we look at the sustainable nature of any resource means that we have to balance what that resource is being used with. I call it balancing the drive to exploit with the need to conserve. Those are the two things that we're balancing. We need to conserve water, but we're driven to exploit it by the way we live and the number of people that we have in the world. And I mention that point before I get to the next slide every time because as the United States, you'll frequently find us on the high end of every chart for resource exploitation. If you look at liters of water per person, so this is average daily water use per person in terms of liters of water, United States,